Howdy folks. Let's say you want to make a three-dimensional model of a relatively simple molecule like glycerol right here. But let's say you want to have control over the rotation around any of these bonds for the different functional groups. So how can you do that? You can download a three-dimensional molecular model from lots of places on the internet, but how do you get control over the rotation? Going to use this program called Blender. Blender is a open source, free to use, and extremely powerful animation software package. One of the problems with extremely powerful is it's also a little bit confusing when you're first starting to use it, and there's a fairly steep learning curve. So I would suggest you might want to start with one of those Blender tutorials made by somebody that actually is a Blender expert, because I am definitely, totally not an expert at using Blender. And I also have no artistic ability whatsoever. But if you want to follow along and do what I did, you can go to blender.org, click download, do all the usual stuff, waiting for it to download, and then launch the executable file. But you can see that people that do have talent and people that do know how to use Blender can make some pretty amazing stuff. So you might want to look at some of that while you're waiting for it to download. But once it does download and you open up Blender, the first thing you'll see is a rectangle that's asking you what language you speak and where you are and things like that. But the next time you open up Blender, you're going to get this splash screen. So we can make a new file, General 2D Animation, Sculpting, VFX, whatever that is, Video Editing. Okay, we'll use that later. You can also send them some money because it is a free-to-use software package, but they don't make any money unless people send them money. And it's, better than most of the video games I've played, so you might want to throw them a few bucks. Let's go ahead and click on General. So we have a vast, featureless plane in a three-dimensional coordinate system. So here are our coordinates, x, y, and z. We have a very plain gray cube in the middle, centered at the origin. Actually, if you go over here, it tells you here's everything we have. So there's the cube highlighted. Camera is telling you the view that the camera has over the cube if we were going to render this animation. And you can see what the camera view is by clicking on this movie camera icon. So that's what the cube would look like from the camera's point of view. You can click on the camera icon again to go back to where you were. We also have a light source that's over there. We'll talk about all these here in a bit. Now, the first thing I did, I just downloaded the latest version a couple of days ago, but I edited the preferences to do a couple of things. So the very first thing, I changed the resolution scale to 1.25 to make all these numbers a little bit bigger. And then under System, I clicked on CUDA to tell it that I have this kind of graphics card in my computer. And again, I'm not a Blender expert, but I'm told that either CUDA or Optics if you have an NVIDIA graphics card, or HIP if you have a graphics card from AMD. And the other thing I did is I changed the undo steps to 256 because I'm an idiot and I often make mistakes and I want to be able to hit Control-Z at least a couple hundred times, maybe as much as 256 times, to get back to the last place where I hadn't screwed anything up. Over here where the three lines are, you can save the preferences. I do have autosave preferences clicked, but belt and suspenders, you can also click on Save Preferences to make sure that you've saved it. It says Preferences Saved. Okay, so this is called the viewport, where we can see our plane and our cube. Over here is the scene collection. Over here we have all sorts of options. We can do all kinds of things. Right now it's on object properties, so that's telling me the cube is centered at the origin. and I haven't rotated it around, and it's got a scale of this. So we can change these. You can either type in a number or you can click and drag. You can move it along the x-axis. Control Z. You can move it along the y-axis. Control Z. You can move it up and down in the z-axis. You can rotate it. You can do all kinds of stuff. But here where it says scale 111, okay, we can change our point of view by clicking and dragging on one of these handles on the coordinate system. But we can also click, and now I'm viewing straight down the negative y-axis. So there's the x-axis as the red line, positive x off that direction. And there's the z-axis, the blue line. But the scale is 111. There's the origin of the coordinate system. Each one of these boxes is 1 meter. Well, for the molecular model, let's call it 1 angstrom instead of 1 meter. But notice it's 1 in every direction from the origin. Okay, let's build ourselves a simple molecule like methane. I don't have any cubes in methane, so when cube is highlighted, I'm going to press delete, and the cube went away. I'm going to drag this over a bit until I can see that icon, new collection. So I'm going to leave the camera and the light in their own collection, and I'm going to build my methane molecule down here. And you can change the name like I just did. The first thing I want for my methane is a carbon atom. Add, mesh, UV sphere. I don't know why plane, cube, and circle are just plane, cube, and circle, but sphere has a UV. I don't know what the UV means. Again, I'm not a Blender expert, but UV sphere. We can zoom in and out with the mouse wheel. Well, it's a sphere, but you can see that Blender is treating it as a network of polygons. You can actually, up here where we got these 4 circles, you can click on this one, viewport shading as wireframe, and you can see the edges and the vertices and the faces, and you can do all kinds of stuff with that. This is where we were, viewport shading solid. This third one is viewport shading material preview. Well, we haven't defined a material yet, so it's even more featureless than the gray thing we just looked at. This one is viewport shading rendered. This is what it's going to show you what it looks like after it's done all the math and rendered things. Except right now, it's still treating it like a mesh of polygons. That's fine. It will render like a sphere, but if you want to not look at the polygon, you can come to Object, Shade Smooth, and it'll go ahead and make it a nice smooth sphere. This is going to be my carbon atom, so I'm going to change the name of the sphere to carbon. And I'm going to define a material property for carbon. So that's down here, this red globe thing, material properties. New. Carbon. Again, we have lots of options that I don't know what they do, but I'm just going to change the base color in red, green, blue to pure black, 0, 0, 0. Now, by the way, I'm using RGB because that's the kind of thing I'm used to, but in Blender it doesn't go from 0 to 255, it goes from 0 to 1. Gotta change that back. Okay, so there's my carbon. It's a sphere. But again, it's now 2 angstroms in diameter if I'm using each one of these big boxes as an angstrom. Well, that's too big for my ball and stick model. So object properties, the orange square with the right angles in the corners. It's centered at the origin. It hasn't done any rotations, but I'm going to change the scale. So for my ball and stick models, 0.25 in all 3 dimensions. So now there's my carbon atom centered at the origin. I can go up to File, Save As, Blender, make myself a new folder, methane, and I can make a new file, methane ball and stick. Okay, methane ball and stick. So there's my first ball. Now I need my first stick. Add mesh cylinder. Again, it's way too big. Object, shade smooth. For the scale, I'm going to make it 0.05 in X and 0.5 in Y. Now for right now, I'm leaving it a scale of 1 in Z. But again, that's from the origin in each direction. So for a carbon-hydrogen bond, let's say I want the bond length to be, what, 1.1 angstroms? So for my scale in Z, that needs to be half of 1.1, 0.55. And then I want the bond to be going straight up, so I'm going to move it up 0.55. So it moved the origin of this cylinder from at the origin of the coordinate system up 0.55 angstroms. So there's my first bond that's slightly longer than 1 angstrom, 1.1 angstroms. I can change the name to bond. I can define a material for the bond. I'm going to make it a nice neutral gray color. And now you can see the effect of the lighting when I'm looking from the wrong side. Okay. So there's my first bond and my first atom. Okay. For the additional bonds, I can just click on this one and duplicate it. I don't have to do the whole add mesh, cylinder, etc., every time. I can just duplicate this bond. And then it gives me the option of putting it anywhere I want. Or I can right-click and it puts the new bond right on top of the first bond. So there's the first bond, there's the carbon, there's the second bond. Notice how it incremented the name from bond to bond 0.001. So this is my second bond. I'm going to rotate that. But if I just rotated it here, it's rotating about that origin. Well, I don't want that. Control Z to undo. I want it to rotate about the origin of the three-dimensional coordinate system. So for bond 1, object, set origin, origin to 3D cursor, and now see how the orange dot moved from the middle of the cylinder to the middle of the carbon atom, which is at the origin of this three-dimensional coordinate system. Now when I do my rotate about Y, and I'm assuming it's a perfect tetrahedron, oh, that's better. So that's a useful feature. You can change the origin, and when you're done, you can change it back. You can do all kinds of stuff. Let's make my other two bonds. Object, duplicate, right-click, object, set origin, 3D cursor, 109.4712, and for the third bond, I'm going to rotate about Z by 120 degrees. So there's my third bond, which is now bond 0.002. Go back to the first one, object, duplicate, right-click, object, set origin to 3D cursor, rotation, 109.4712, minus 120. So here are the 4 bonds for my ball and stick model of methane. Now I need some hydrogen atoms. I could do the duplicate trick with carbon, but then because I'm an idiot, I will forget to change the material, and so I'll just have carbon atoms everywhere. So I've found it's easier for me to avoid making a mistake if every time I start a new element, I just make a new sphere. So add mesh sphere, object, shade smooth. We'll scale it. But now I want my hydrogen to be centered around the end of that bond. So now I'm going to go up 1.1 angstroms. Okay. So now the origin of my new sphere is 1.1. One big box, one little box in the z direction. Okay. I'm going to rename sphere to hydrogen. I'm going to make a new material for hydrogen. I'm going to change the base color to pure white. So 111. Okay. Well, I'm going to do the same thing with the hydrogen atoms that I did to duplicate for my 4 bonds. So I've got the hydrogen highlighted. Notice that the thing that's highlighted on the list has this orange outline. Object, duplicate, right click, object, set origin to 3D cursor. Object properties, rotate about Y, 109.4712. Oh look, well that's much more easy. Object, duplicate, right click, object, set origin to 3D cursor. Rotate about Y, 109.4712. Z, 120. Object, duplicate, right click, object, set origin, 3D cursor. 109.4712 minus 120. Okay, well that's pretty easy. So there's my ball and stick model of methane. So there are my 4 bonds. There's my carbon atom. Here are my 4 hydrogen atoms. And since I did the set origin to 3D cursor and I did the rotations for the hydrogens the same way I did for the bonds, there's bond 001, there's hydrogen 001. There's bond 002, there's hydrogen 002. I'm trying to make it harder to screw things up. Now if I just click on the carbon atom and I try to rotate that about the z-axis, it doesn't look like anything's happening. By the way, rotating is I'm clicking and dragging left and right. Well, it's because it's a sphere. It's rotating around at the center of the sphere. Well, okay. I want to rotate the whole molecule. So I'm going to tell Blender that all of these parts are connected to the carbon, and that's called making a parent. So I'm going to click all my hydrogens, shift, click, click, click. I'm going to click all my bonds, click, click, click. Notice the last thing I clicked has a yellow outline, and all the previous things I've clicked have an orange outline. And then my last shift click is going to be on the carbon. Now the carbon has the yellow outline. Object, parent, object. So now in my scene collection, it just says carbon, but it says it's got 8 things belonging to it. I click the down arrow, there they all are. My 4 bonds and my 4 hydrogens are the 8 things that are children of the carbon. So now when I click on carbon and I rotate about the z-axis, the whole molecule is rotating. Or if I rotate around the y-axis, okay, I can also change the location with the click drag trick. Or another way to change location, you can press G on the keyboard, G for grab, and then just move it anywhere you want. Left click to keep it there, or G, drag. Oh, I didn't want to do that. Right click to snap it back to where it started. So there's my ball and stick model of methane. Okay, fabulous, wonderful. I want to make it pretty when I look at it in the camera, or at least prettier than it is now. Because now if I go to render image, so that's kind of what we were looking at in the camera. By the way, notice this is a new window. So there's the ball and stick where I was doing everything, and this is the render window. But it's pretty gray and dark and not very useful. Okay, so I like the fact that I can specify exactly where every atom and bond is. Well, a way to make that easier, I'm going to make my standard view looking down the negative y-axis. So I want my camera to match that view, and right now it doesn't. So I can go up to camera. So these are the coordinates and the rotation angles for the camera right now. I'm going to make that 0, minus 25, 0, 0, 0, 0. Now my camera is 25 angstroms away from the molecule, but it's looking down. So rotate about X, 90. Now my camera is looking toward the molecule. Okay, that's a little better. Now my light source is not at a good spot. So I want my light source as though it's looking over my left shoulder. I'm sorry, my right shoulder. So for light, okay, so a little bit to the right, let's say 20 angstroms. Back on the negative y-axis, negative 20. A little bit up. And it's a point source, but I'm going to change the rotations to 0 because it looks better. Now when I look at the camera view, oh, it's really, really, really dark. Okay. So with the light highlighted, see how this looks like a light bulb? Object data properties. If the camera was highlighted, now object data properties looks like a camera. If the molecule is highlighted, object data properties looks like a geometric mesh. I click on light. I'm going to click on the light bulb. I'm going to go to Home Depot and get a 25,000 watt incandescent bulb. Okay. Now at least my light source is over my shoulder, so it's highlighting the molecule from the side I want it to. But my background is still horrible, ugly, dark gray. Okay, I'm going to add a background. Now I want the background to be under this thing with the camera and the light, not under the molecule. So I'm going to click on this collection, add mesh plane. It added it in the XY plane. I click on object properties, rotate about X by 90. Now it's in the XZ plane, but it's right at the origin, slicing right through the carbon. So I'm going to move it back by positive 10 in the y-axis. And I want to make it big enough to cover the whole background. So scale in X, 10, no, a little bigger, 12, okay, a little bigger, 13, okay. So now it's going just past the edge of the camera view. And then in Z, I'm sorry, in Y. By the way, it's rotating, it's scaling in Y because the y-axis flipped when we did the 90-degree rotation about X. The who with the what now? Doesn't matter. 5, not big enough. 10, too big. 7.5. Okay. So now there's my background. So I'm going to change the name from plain to background. And I need a property, a material property for the background. I want it to be a color that's not as horrible as this gray, but I want it to be different enough from the white of the hydrogens that I can see the hydrogens. So I'm going to make the base color like a nice gray blue. I'm going to change the red to 0.5 and the green to 0.5 and make the blue 1. And so there's kind of a blue-gray background. Now when I go to the camera view, okay, it may not be pretty, but it's at least usable. With the light source coming from over my right shoulder, there's the molecule, there's the shadow. So Blender is smart enough to calculate where the shadow should be. So there's background camera light, there's my molecule. Save. Now I want to see what this looks like when I render it, but I might have to change some of the properties. So see this thing over here that looks like a camera? Render properties. Render engine. There are different engines we can choose, and I don't really know how to tell which one would be best, but I know that Cycles works for my computer. So I'm going to click on Cycles. Featured set supported or experimental. I probably don't want to mess with experimental. And then what's going to be doing the calculating when I render? Well, it could be the central processing unit, but I'm going to make it my graphical processing unit, the graphics card. Okay. Then for sampling, this is the number of iterations that Blender is going to go through the arithmetic to go from the wire mesh to the nice smooth sphere. It's defaulting to 1K when we're looking at it in the viewport, but 4K samples when we're rendering it. Now, I've learned that for these nice simple ball and stick models, that's more than I need. So actually looking at it in the viewport, just 2 samples is good enough. And when rendering it, 16 is probably good enough. Now, one of the reasons why I learned to do it at those very small numbers of samples is when I was doing Blender on my laptop, which doesn't even have a graphics card, even 16 samples when rendering would take minutes per frame. And so I'd have to render an animation, it would take 24 hours. Okay, what else do we got? Performance? You know what? I'm just not going to mess with any of those other things. So, Cycles, using my graphics card, small number of samples even when rendering. And then for the output, so the thing that looks like a printer is the output. There's my screen resolution. I'm happy with that. For animations, I'm going to change the frame rate to 30. Not that it makes a huge difference, but okay. It matches what OBS is using as I'm recording this screen. And frame start, frame end, so it's a 250 frame animation by default right now. And where do I want the output? Blender, methane, render, methane. And then I'll just name all these files methane as well. So where's it going to send the rendering documents? Blender, methane, render methane. Okay. Render image. I mean, it's still not a work of art, but it's better than it was. It's not the horrible featureless gray background. It's now a horrible featureless slightly blue-gray background with some highlighting from the light source and a shadow. That's good enough for my students. File, save. Now I want to animate this. Okay, so that's this stuff down here. I'm now going to drag this up a little bit. So see how it says playback keying, and here's the 250 frames that it's assuming by default. And right now I'm at frame 1. We can also tell that there. So let's make the molecule just tumble across the screen. So I can press, oh, I want to make sure I have the carbon highlighted. Press G, I'm going to drag it up here, where it's just off the field of view of the camera. Click on Object Properties, so there's the X, Y, and Z for that position. I'm just going to rotate it kind of semi-randomly for a starting position. And I'm going to move it up just a little bit more so the hydrogen's off frame. Okay. That'll be my starting position. There are a lot of ways to tell Blender that this is a critical frame or a keyframe. But I can also, because I like to define everything over here, I can go over here where it says Animate Property. I'm going to animate the three-dimensional location, and I'm going to animate the rotations. So now they're gold, and now there's a diamond there at frame 1. Okay, I did 30 frames per second, so let's say 4 seconds later, that'd be 120 frames. So at frame 120, press G to grab. I'm going to move the carbon down here. Blender's smart enough to tell me, hey, I just changed these guys because those coordinates are now in orange. I haven't changed those guys. Those are still green. Okay, now I'll make it rotate about the x-axis by, I'm just going to randomly type in a number, 1,276 degrees. And now I'm going to animate my 3 coordinates in location and my 3 coordinates in rotation. And now there's my orange diamond at frame 120. Okay, so the left and right arrows will move you frame by frame. You can also do down arrow to get to the previous keyframe, or up arrow to get to the next keyframe. If I press up arrow again, well, there is no more keyframe. So no more keyframes to jump to in this direction. Down arrow to go back to 1. Okay, I'm only using 120 frames, so I can make the end 120. And watch what happens to this gray when I press enter. Okay. I can preview what the animation looks like, so I have my cursor down here, and I press the space bar. Okay, it's not going to win any awards, but it's good enough. Okay, arrow back to frame 1. File, save. I think I'm ready to render my animation. So let's go back over here, render properties. That still looks good. Output, okay, ending at frame 120. Now here's an important trick. I could choose to render this as an MPEG and just go straight to a video. We got lots of other choices too, and most of them I don't know what they are. I am going to render each frame as an individual PNG file. So when I'm rendering, I'm actually going to end up with 120 PNG files. Now the advantage to that is if I did something stupid and it screws up halfway through, if the first 60 frames are okay, I don't have to re-render the entire thing from scratch. I can just fix whatever's wrong and then start rendering again from frame 61. Rendering as PNG files and then stitching them together later actually saves a lot of trouble if anything goes wrong. Okay, render. But now render animation. So now here's my new render window. For frame number 1, it's doing its samples. Right now it's telling me it's on sample 9. Now frame 2. Now frame 3, the hydrogen still hasn't come into the field of view yet. So we'll wait a few minutes and we'll come back after it's finished rendering. Oh, actually, before I do that, while it's rendering, click Blender, Methane, Render Methane. Here's each of the frames it's already rendered. 1, 2, 3, 4, 5. Okay. So we can watch those show up as they're done. Okay, now we'll come back in a few minutes. A few minutes later, it's just finished rendering frame 120. So if I go back to my folder, my render methane folder, there's frame 120. There's frame 1. 757 to 813, so that took 16 minutes now that I have a computer that actually has a graphics card. I can close the render window. It's got an asterisk, so it's not been saved since the last thing I did, so I'll save it. Now I want to stitch those 120 PNG files into an MPEG. So now I'm going to go to File, New, Video Editing. Down here in the sequencer, add image sequence, Blender, Methane, Methane Render. Here's all my 120 PNGs. I can just click A on the keyboard to select them all. Add image strip. Okay, there's my images. Again, it thinks it's 250 frames by default. I'll make it 120. Again, see how the gray came down there. I can do my spacebar trick. And there's my preview. Okay, I can go back to frame 1. So now we need to do the render properties and all that stuff again. Cycles, GPU. The sampling doesn't matter now because it's stitching together the PNGs. Output, 30 frames per second. Blender, Methane, Render Methane. Now I'm going to call it video. And this time I do want to render it as a FFmpeg format. This is not going to take 16 minutes. Now when I go to render animation, it's very quick because it's just stitching together the PNGs that are already done. So it's already done rendering. Let's see what it looks like. So again, not a work of art, but it's good enough for my students. So let's go back to our methane. Now it defaulted back to the solid view for viewport shading. I want to go back to the rendered view. What if I want a space filling model instead of ball and stick? It's actually pretty easy. So I'm going to click on carbon. I'm going to go to my object properties. I'm going to put it back at the origin with no rotation. But now if I tried to change the scale, it changes the scale of the whole molecule. So I need to unparent it. So I'm going to make sure all of these parts are highlighted. Object, parent, clear parent. Now when I go to the carbon, I can rescale the carbon, and I'm going to make the scale equal to the van der Waals radius I want to use, 1.7. And it just scaled the carbon atom. That might look huge, but that's actually right. I'm going to undo that for a second so that I can see what happens to the hydrogens. So there's the first hydrogen. I'm going to make that 1.2. Okay, that looks okay. If I click on the second hydrogen, that's not right. Well, that's not right because the origin for the second hydrogen is still at the 3D cursor. The origin for the first hydrogen was in the center of the hydrogen. So I need to undo those last changes. So for the first hydrogen, the origin's in the center. For the second hydrogen, in the center of the geometry. For the other hydrogens, the origin's still at the 3D cursor. So I'm going to change that. Set origin to geometry. See? Hydrogen 2. Set origin to geometry. Hydrogen 3. Set origin to geometry. Now I can scale all of the hydrogens. Can make sure they all look right. Okay. And I can scale the carbon. Okay, so there's my three-dimensional space-filling model of methane. Okay. Now, I moved it to this origin to make it easier to do all that changing the scale stuff, but I didn't change the keyframes. So if I go to the last keyframe and the first keyframe, oh, no, wait, no, I got a problem. It's just moving the carbon. Okay. So I'm going to finish scaling the carbon. But now I need to make everything parented again. So I'm going to click the hydrogen. This time I'm going to do control click instead of shift click because I'm going to skip over the carbon to select him last. So there's my 4 hydrogens. There's my 4 bonds. Now control click on the carbon. The carbon's yellow. He's going to be the parent when I do object parent object. Okay. Now I can go to my keyframes. Now I can do my space bar. I didn't have to change the animation at all. All I had to do is rescale everything and then reparent everything. And now I've got a space filling model animated. Okay, so Blender, it's pretty cool. It can do lots of stuff, even though I have no artistic ability and even though I don't really know what I'm doing. So I can save as methane space fill. And now I can render this. By the way, let me double check that the rendering's still ready. Okay, I'm going to make a new folder. Render methane space fill. Except now I can render that one. Okay, the space filling methane has finished rendering. Save, file, open. Oh, new, video editing. Add image sequence, Blender, methane, render space fill. A for all, add image strip. Change that to 120. Cycles, GPU, 30. And we can just render this one too. So all we had to do is spend the 15 minutes to change the scale and everything and render it again, and now we've got space filling as well as ball and stick. Now actually, it's not perfect. You can still see some of the leftovers of it being a wireframe mesh instead of an actual solid object. But that's good enough for my students. If it's not good enough for your purposes, then you can change the number of samples to really big numbers and just wait longer for it to render. Okay, I think that's enough for now. In the next video on how to make three-dimensional models in Blender, we're going to actually do the functional group rotation thing and build ourselves another copy of Glycerol. Thanks very much. Talk to you later. Bye.